Okay, welcome back everybody to our CBI Fellow session now. So we are going to be presenting talks from the first and second cohort of CBI Fellows. Uh, First up, so we have William Agnew. So he's a researcher from the inaugural cohort of CBI Fellows, working with Professor Souvik Das. His academic endeavors are motivated by using research and organizing to challenge power and technologies that concentrate power with the goal of empowering marginalized communities over tech, data, and AI impacting them. He founded Queer in AI in 2018 to make the AI community more accepting of queer researchers and raise awareness of problems that AI can cause for queer people. He'll be presenting the work on protecting your voice from AI. And so welcome and looking forward to your talk.
Yeah, thank you for the introduction. So again, I'm William Agnew, and yeah, I wanted to talk about some tools that I've been developing with Shavik and many other collaborators on kind of empowering end users, improving their security in relation to AI. So specifically, I want to talk about protecting your voice and other types of audio from harmful AI or malicious AI. So audio AI has really improved quite a bit over the last few years. One example of this is voice cloning. So in voice cloning, the problem is given a sample of your voice, produce a new audio of your voice saying some new text. And voice cloning works extremely well. Given only about 10 seconds of a person's voice, modern voice cloning tools can produce a very convincing clone of that. And this is exciting. It has applications in AI assistance, in accessibility, and in many other areas. However, voice cloning has quite a few ethical issues as well. Primarily, impersonation and fraud. Voice cloning is being used pretty widely by scammers to run these new types of scams, where, for example, a man in California was scammed out of $25,000 when people voice cloned his son and then called him with his son's voice, and was like, "Oh, there's an emergency. I need you to transfer $25,000." Similarly in Wichita, a mother received a call from a voice clone of her son saying that, "I'm in jail. There's been an accident. I need $25,000 in bail," and she almost, sent that to an account. So voice cloning is really changing this dynamic where, in the past, if you heard someone's voice, it meant it was them, and that is no longer true. And we are really going to struggle to adjust to that. There are also a lot of intellectual property issues with voice cloning. So professional actors, voice actors, narrators, and other people have something that they call their voice print. So the sound of their voice, their timbre, their tone, their intonation, even their personality, all make up this very important kind of professional thing for them. And voice cloning can take that without authorization and then use it to record new audio and kind of undercut them. So famously, OpenAI came out with a virtual assistant that sounded exactly like Scarlett Johansson, but did not get her permission to sound like her, and was like a lot of bad PR for them. She ended up suing them, and they had to take that particular voice assistant down. So the ethical issues with voice cloning have prevented wide deployment of voice cloning tools. OpenAI, Microsoft, and Google all have voice cloning technologies that work very well, but you can't use them because of these PR and legal risks that they would face if they deployed them. And existing deployers are also facing a lot of PR and legal risk. Consumer Reports is going after existing deployers. They're facing a lot of lawsuits. So these ethical issues have really prevented this technology from being commercialized successfully. Another type of audio AI that has taken off really just like the last year and a half is music AI. So by music AI, I mean extending and remixing music. So given a sample of music, extend it, remix it, modify it, change in other ways, maybe switch up the genre, add in lyrics, all sorts of very exciting things. And about a year ago, we had Suno and Udio, two music startups, come out that do pretty well in this task. And then about a month ago, UA It's the first kind of open source music model that does decently or well, in my opinion. And music AI can very convincingly replicate voices and styles of specific artists. I'm sure a lot of you have heard like Taylor Swift singing things on TikTok because music AI has kind of cloned her voice and style. And music AI has a lot of like really cool applications in music creation and DJing, accessibility, also in audio understanding and search. So it's a very cool and promising set of technologies. But it also has some ethical issues that's been holding it back. So primarily intellectual property theft, so taking an artist's voice or style, using it to generate music that then economically undercuts them, and also bias, concerns that this model won't perform very well in certain genres of music, and then those artists in those genres won't be able to take advantage of these tools. So a lot of these music AI startups are facing, significant PR risks, a lot of lawsuits, a lot of other issues that again are preventing this technology from seeing widespread adoption and commercialization. So, in audio AI, kind of what we're seeing is that there are very promising tools out there, but the ethical issues are preventing successful adoption and commercialization of these technologies. So it's really important that we address them if we want them to be widely used and to be used in a positive way. So in the past year and a half during my fellowship, some of my work has focused on addressing these issues. So first I'm going to talk about the work I've done on addressing training data ethical issues. So to do this, we conducted the first audit of audio data to understand biases in this data set and the presence of copyrighted information in these data sets. Our first question was, what datasets are even used for training audio AI? Even that information wasn't really present out there. So we found that there are hundreds of audio datasets in use. Many of them are like very custom and purpose built. There's like a very large like Irish folk song dataset out there. All these genres will have specific datasets, but most of those are quite small, not of the scale needed to train kind of these large-scale foundation models that you see out there. We did, however, find a smaller number of very large and very popular data sets that are of the scale needed to train kind of these general purpose models. So things like LibreSpeech, which comes from an open source data set of audiobook narrations, AudioSet, which is pulled from YouTube videos, datasets pulled from online music streaming services, and various free music archives were all quite large, quite widely used. So we decided to focus our audit on these 6 or 7 datasets because they're really representative of the field. So the next question we asked is, are these datasets biased? And we just looked at kind of common biases that we know show up in AI. So the first thing is, what language are these datasets in? And we found that most of these datasets are mostly in English. However, one dataset really stood out, the Mozilla speech dataset of just people reading different sentences is actually majority non-English. They have a very wide representation of non-English languages. And that's because they've been very intentional about this. They constantly measure and benchmark themselves, and they find that they are lacking in a particular area. They're very proactive about changing that. But most of these other data sets aren't like that. They're just scraped from the internet, put out there, and then people use them without really understanding what's in them. Next, we looked at binary gender bias. So specifically, we looked at which words are most commonly associated with women in the text of these data sets or the transcriptions of these data sets, and which words are most commonly associated with men. And if you take some time to look at these, a few things stand out. For men, we see the most common word is war. There's also peace, land, horse, power, kill, nature, history. A lot of like very kind of stereotypically like fighting, violence type words. And for women, the most common word is store. And then there's a lot of like relationships of like aunt, princess, queen, gentlemen, just like people around them. And these are encoding some like stereotypes that we know have done a lot of harm that aren't representing people accurately. So it is concerning that kind of this is the data we are training these models that are supposed to be of the future on, but they seem to be representing very stereotyped, old-fashioned views. Another important question is who is in these data sets? And we unfortunately found that this information wasn't really present. Like, we don't know who the speakers, the musicians in these data sets are really. That wasn't included with them. But we were able to look at identity keywords mentioned in these data sets to look at who's being talked about in them. And again, just be aware that this graph is log scale. So even a tiny difference between bars is quite large. But we found that men were talked about the most, about twice as often as women. And we found that there are many identities that are represented very, very infrequently at all in these data sets. And then finally, we looked at, what licenses are the data in these data sets under. And we found that there are a few of them, specifically Mozilla Common Voice, that's under Creative Commons 0 license, which is very permissive. CC0 lets you do basically anything with this data. But for most of the other data sets, they're under a variety of licenses, so different Creative Commons licenses. And some of these CC licenses prevent remixing, some of them prevent commercial use, all things that can pose legal risk if like a startup were to take and use these data sets. And then AudioSet, one of the most popular data sets, a lot of its data is actually under the YouTube license, which basically means that Google can use this data for Google things, and otherwise you have to go to the owners of that data. So that licensing is very unclear. And then Lock, which is also very popular, is under the Echo Nest license. Echo is a old music company from the 2010s, which was bought by Spotify. So presumably Spotify now owns the license to this data. Again, that could pose a concern if you were to take what is now Spotify's data and try to use it to make a product. So key takeaways from our audit. Many of the audio data sets are under licenses that may prevent commercial or AI use, so there are legal risks to use them. Many audio data sets are biased towards English and don't include many mentions of marginalized groups, so they will perform worse for these people. And large audio data sets are typically scraped from YouTube or very specific websites. So a few actors control most of the data, which is very different from image and text domains. So to address some of these issues we found, specifically lack of documentation, we propose data sheets for audio datasets, and this is an open source guide for documenting and understanding audio datasets. It's about 120 different questions that people can fill out, and it lets people quickly understand, what's in this dataset, how can it be used, how should it not be used, what do I need to know about it. So the next work that we're just finishing up now is about addressing ethical issues with the usage of audio AI. So specifically, we are proposing audio data defenses to prevent malicious use of voice cloning and music extension tools. So the attack setting that we're worried about is we have this emoji person here, Alice, and she is posting a video game review to YouTube, which is very, very common for YouTube. And then an attacker is going to rip Alice's voice from that public YouTube recording, make an AI voice clone of it, and call Alice's mom and say, "Hello, mom, this is Alice. Please transfer $5,000 to this bank account." And if your mom is like my mom, she would probably do it. And this would take me like literally a minute to do from YouTube video to voice clone. It's shocking how easy it is. These are all publicly accessible, free to use tools. I think this is a very critical vulnerability we have. So what we do is we add a defense to Alice's audio. And this defense changes the audio slightly. It's like a very subtle noise to this. You can still understand it. But when the attacker uses AI voice cloning, the voice cloning outputs something that is either incomprehensible or doesn't sound like Alice. So to get a little more specific, the way we do this is we add a small distortion to protect audio. And we create this distortion by solving a multi-objective optimization problem where we want to do two major things. We want to minimize the human perceptibility of the distortion we're adding. So we want the protected audio to sound as similar to the original audio as possible, but we want to maximize the impact of the distortion on the AI. So these kind of two terms are slightly in conflict in our optimization problem, but we have a lot of cool algorithms we've used to solve them. So more specifically, we want to minimize the negative cosine distance between the AI encodings of the original and the distorted audio. So by AI encoding, the way audio AI works is it will take in the waveform of the audio and we'll kind of compress that to a vector of like length 256. And you can think of that as like a direction in a high dimensional space. And we look at these two vectors and we take the cosine distance between them as a metric of like how similar they are. So we want them to be very dissimilar. And then we also want to minimize the human perceptual distance between original and distorted audio. And we're using kind of a series of Mel spectrograms for this. But human perceptual distance is actually still a very hard problem to measure algorithmically. And then we have this last thing that we've added on. We want to minimize the magnitude of the denoised, distorted, or protected audio. So a lot of these systems will use very sophisticated denoisers when voice cloning. So this lets us attack them at the denoiser and at the cloning as well. So now I'm going to show you some of our results, and these are like still somewhat in progress, so please be gentle. But overall, we found that this does work, and the more distortion you add to the original audio, so like the stronger the protection, the more distortion the AI generation has. So because of this, and after chatting to some potential stakeholders, we've kind of split our protections into low, medium, and high levels. So at our low level, our goal is that the distortion is barely perceptible. And of course, this means that the protection, the impact of the protection on the AI generation is much smaller. At a medium level, the distortion is sometimes noticeable, and the quality of the AI generation is noticeably lower. And at a high level, the distortion is definitely noticeable, but the AI is unable to make a coherent or like rational generation. So now I'm going to play some audio for you. So here is our just normal unprotected base audio. This is what would be uploaded normally. So you have this like kind of relaxing piano with some like xylophone or something. Then here's what UA, which is a state-of-the-art open source music extension model, does with this when I just ask it to extend it. So like it doesn't sound perfect, but it's like pretty good. It's like kind of gotten the tune and the melody. It's like adding like a little like jump to it or something. So it's doing interesting stuff with it. And I'm going to play for you. Here's the original audio with our protection added. And this is at a high protection level, so the noise will be pretty noticeable. You'll definitely hear some static. So it kind of sounds like a bad compression or something, but it's definitely still the same audio. And this is what happens when we ask UA to extend that audio. In the darkness I'll whisper. So it obviously does a terrible job with that. Like if you were to tell me that this is an extension of that original audio, you would just laugh because it's some like weird country thing going on. So that's kind of what we want. We want somebody to be able to say, I don't want anyone to take my music or my voice and extend it without my permission. And if they do that, this happens. So now I'm going to show you a medium level of protection. And this is with voice cloning. We're using XTTS, which is one of the better open source voice cloning models out there. And we're going for a medium protection level. So we want to noticeably degrade the generation. It's not going to sound completely incoherent, but it's going to be noticeably worse. And it's going to be the cost of like some noticeable distortion to the original, but hopefully a bit less. So here's the unprotected voice clip.
If the red of the second bow falls upon the green of the first, the result is to give a bow.
So it's this person reading a newspaper article. And here is the XTTS voice clone of that person.
The quick brown fox jumps over the lazy dog.
So it's like shockingly good, and that's only from 11 seconds, which is disturbing to me. And here is our protection added to this original audio clip.
If the red of the second bow falls upon the green of the first, the result is to give a bow with an abnormally long.
So it sounds like kind of a bad phone call, but it's still definitely that person. And then here is our AI extension of XTTS trying to attack our protection.
The quick brown fox jumps over.
So it's still saying something. It's not saying everything it was supposed to, and it's definitely not the original speaker. So we count that as a success. Like if you were to try to use that to do an impersonation attack on that speaker, you would just fail. So now I'm going to play for you some low levels of protection, and these are much more subtle. For these, we're really thinking about professionals. So we've talked to a few music and voice acting professionals, and they have extremely good ears. You know, for them, if there is like an iPad in the recording room, the reverb from that iPad is like too much noise. So this will be much more subtle. So again, the base audio is the same as the first time. And then here's our protection added to that base audio. So if you listen closely, you can hear like a little bit of static, especially in the more quiet parts. And then here's our AI extension of that audio. So it starts off pretty good, but then when we go kind of to the middle of the generation and we start playing, we hear this. So it's actually gotten the AI stuck playing the same few notes over and over and over for like the last 30 seconds. So, you know, it's kind of a much more subtle distortion of the AI, but if you are like a professional, like if you were using this to like produce music for a game that you're trying to steal somebody's style, that wouldn't be acceptable. So yeah, we have a lot of next steps with this. We're hoping to kind of test and co-design this product with potential user groups, you know, voice actors, musicians, YouTubers, audiobook narrators, people speaking on video game chat systems, and really anybody else who's worried about kind of impersonation, to really hone in on, you know, what levels of distortion are acceptable in our protection, what levels of protection are needed in the generated audio, and what are the unique needs of these kind of different markets. Yeah, and thank you. You know, thank you to everyone at Carnegie Bosch for making this kind of risky, out there idea possible. You know, to my mentor Shavik Das and many other collaborators. And any questions?
Hi, great talk and really interesting work. So neat seeing all those demos of the results of your work also. My question is about, I guess, the sort of use cases or sort of threats you're anticipating with use of this technology. So you sketched out like possibilities of malicious use with voice cloning. The other thing that came to mind was protection against use for training of generative AI in terms of like intellectual property management.
Yeah.
Any thoughts on that? And if you do anything different for that particular use case?
Yeah, no, this is an excellent question. So these defenses are really targeting inference times. The AI is already trained and then it's trying to perform inference on your data. They might work on training time. We want to test that. Where there's some reasons why it might work. There's some reasons why it might not work. There was actually a paper that came out, I think 4 months ago, looking at this in the music setting for training, and basically how can you add subtle noise to music so that if an AI is trained on it, it can't like take the style of that music. Like you have to go to the owner of the music if you want to train on it. And they use kind of a very different technical method where they're trying to do something called gradient zeroing, where if you take the gradient of the model with respect to this protected music, they're trying to make those gradients as small as possible. So trying to make it so the model learns nothing. So I think that's super cool work. And you know, after I've finished with this, I want to like dive back into that because certainly that's like another kind of major vulnerability in the audio space.
This is very interesting. One question I have, do you think this might, like if this become like widespread adopted, would this lead to like an arms race between the people developing the protection versus the AI developers for the voice cloning, and you have to keep improving these models and the cloners keep improving their models back and forth?
Yeah, I mean, that's all security. It's this arms race between attacker and defender. I definitely think that would happen if this became more widespread, and that makes, you know, that kind of makes the security setting a little more complicated. Of like maybe previously protected audio is no longer protected, or the protections can be broken. We do have like 11 different countermeasures that we test against, everything from like denoising to adding noise to like different neural networks, just to kind of see like, you know, if people tried kind of all the obvious and existing things out there, would they be able to break this? And it seems pretty robust so far. But I definitely think it would be possible to come up with something that could break a specific version of this. So it would be this arms race, unfortunately.
Hi, thank you for the great talk. I had a few questions. So, like, first of all, I was wondering for the low protection mode, whether you guys tried the human voice variation and like how it performed with that.
Yeah, so I don't have samples with me now, but when we have tried it, it is also very subtle. Typically, the voice will slow down a little bit. They'll sound a bit more stuffy. They'll sound slightly less like themselves. So like if this were like a professional like voice acting setting where you're selling your specific voice, that would probably be enough to make this attack effective. Or maybe if it's like they are trying to scam your family members where they know your voice incredibly well, that would be enough to be effective. Yeah, and we're still trying to like really zero in on what these levels should be. Yeah.
I see. Okay, thanks. And the other question that I had is sort of like goes also to the previous one. So I was wondering if anybody has looked into sort of like, I don't know, some kind of like theoretical, I don't know, like definitions or like, you know, some kind of like measures that you would be able to come up with to show that, okay, like this is like the formal guarantee that we want to have, right? And I mean, like the algorithm satisfies this guarantee, right? And then like you would hope that like whatever attack comes up, then if this guarantee is satisfied, then you wouldn't be able to do anything if anyone has looked into those things.
Yeah, I mean that's kind of the $1 million question. You know, like Zika was saying yesterday, all this is empirical. We don't have any good theory of how neural networks behave. So unfortunately for this, it will also be empirical. But there are other classes of defenses, especially in the voice space, where it's less like protection and more like replacement. So you can replace your voice with a different voice. And then that is like much more robust to any sort of countermeasure. But yeah, this class of attack is always going to be empirical. But hopefully we can get it to a point where even if there are countermeasures, they aren't widely available. I would like to think that these kind of voice cloning startups would not try to break these countermeasures, that they would see that they're actually addressing some of their kind of critical PR and legal issues as well.
Thank you.
Well, yeah, I had the same question. So if you could actually define, theoretical upper bound where you say, okay, it is always protected if I perform this action. But since you answered to that, I think, congratulations, because you just won a trip to the Strip District as an invitee of our CBI at RTC seminars. Because we have a group of people that work on audio AI, and I was just checking online also with our manager, Luca. They are very interested in hearing more. So maybe we can organize something in May. So just wanted to break the news.
Oh yeah, that'd be lovely, because I would love to. I've seen the troubles that audio AI deployers are having from the outside, but getting to talk with y'all, that'd be awesome. Yeah.
Also because applications of this work, I can see just right away is, for instance, we collect data, for instance, in manufacturing facilities, right? So, and one of the problems there, the data are very sensitive, and if you are interested in understanding or troubleshooting machines or trying to use audio-based data or other modalities to detect failures or predict failures, you also probably are getting audio from people working there and so on. And so if you have a methodology or technologies that can actually target that type of signal, remove it, that would be one application that I can think of.
Yeah.
The many probably that Charles or others can come up with. So it'd be interesting to hear you interacting with our colleagues there. So thank you.
Yeah, I'd love to chat with them.
I had a related question actually. I might have missed this, but do you have like some kind of measure of how far away two audios are from each other, or like what constitutes like a distortion enough that it's protected?
Yeah, so for the AI, we look at it's like an encoder architecture. So they take the waveform, produce like an encoding vector, and then we just use like the cosine distance between those two encodings. So that's pretty easy. Cosine is like as good as you get in like high dimensions. For humans, it's very hard. Like a algorithm to measure the difference between two audios that corresponds to human perception is not something we really have right now. Like I can use basically I take Mel spectrograms at different windows, so different resolutions of the audio, and I compare all of those, and that's like about as good as you get. Some people have tried to train neural networks on people's preferences, but those are not perfect and very large and hard to backprop through. So I don't know, it's the science of algorithms and humans and audio is fascinating, and I could talk about it for a long time, but we aren't very good at it right now, which is definitely something holding this work back. Yeah, I guess there have been for the instances of voice cloning, there have been professionals who've gone in and they're like, this sounds exactly like Taylor Swift or Kanye. The professional musicians do have very specific things they recognize as style. They're like, oh, these chords, this is Jay-Z. I just know this is Jay-Z. And I'm like, I don't hear it, but all of y'all agree, so I think there's something here. Yeah.
Maybe one more question, just to sort of add to this, right? So your eventual goal for protection is measured by humans, right? So the maximization of the distortion is also for humans. Would it also, like, is it worth investigating if not humans, but a tool can differentiate that this is generated or a clone? So you add a little bit of noise, but the end goal, the output, is not differentiable by humans, but by a tool. So then, we could imagine having apps in our phone so that every time we get a call, it tells you whether it's, it's AI clone, or YouTube can have, labels. Okay, this might be an AI clone because a computer system can detect that, but a human might not.
Yeah, that's actually a super cool idea. I haven't seen any systems out there that say they are detecting AI generated speech. That's not to say they don't exist. This is like a massive. It's now an industry for text. Like, there are companies that just try to detect this text for you. So I'm quite surprised this doesn't exist for AI generated speech, and it really seems like that should be something that should just be like running on everybody's phone. Like, if you get a phone call and it is like a voice clone, then you should know, just for like scam protection. Yeah, I'll just see if there's something out there. Because like the speech generators they sound good, but they're kind of low tech. Like, they follow specific patterns. I think it's definitely doable.
Sorry, I just had like one more question. So maybe I missed it, but like, how long does it take for them to generate, for example, either the extension or like the other text amount?
Yeah, so XGTS is pretty fast. Probably about 30 seconds on like consumer grade GPU, like 12 gigabytes GPU. UA is extremely slow. I have to use an 80 gigabyte GPU on CMU's cluster, and it takes it like 25 minutes to generate a minute of audio. I know the two startups, Suno and Udio, will generate similar, if not better quality in like 25-30 seconds. So maybe they're like slightly better. But like, speech is very easy. Like, speech is a very constrained space. Like, there's only a certain range of sounds that are speech. So that makes these generators small and fast. Music is much larger. We're really just getting good at music, and these models are, billions of parameters, extremely complex. But I imagine the next few years it'll get better and faster.
I see. Okay, thank you.